Hello, and thank you all for joining me, and thank you so much to WISE for hosting me. I would like to talk to you today about my work with independent project work in school and why I believe it improves the uptake of STEM subjects amongst students. The PowerPoint I'm working from is intended for future reference, and I believe it will be available on the WISE website, so I really apologise in advance for the length of some of my slides. And also just to mention, there is a link to a film that I believe WISE will be putting up on their website that will give you access to a film by Christian Hayward of Queen Mary's about research in schools, and will give you access to one of our project research events, and you can see actually from the students themselves how much it means to them to be involved in the project work. So first of all, slide 2 please. So first of all, let me tell you a little bit about myself. As Dean said, my name's Sue Harris, and Sue please, not Susan, hate that. I work at Benenden School in Kent. I'm the STEM project coordinator and lead technician. So my role includes the support for 3 science faculties, as well as working with universities and organisations to make available a range of independent research projects to students in the school environment, that is. My passion for science really started at quite a young age when my father, who was a patents agent for Unilever, brought home some amazing and wonderful substances, and one I remember really well was a white powder. No, it was a white powdered substance that when you added water to it, it expanded exponentially but still remained dry. Now, I thought this was absolutely incredible. I couldn't fathom it out. How did it work? What was it? What was the chemistry behind it? And my father had a real problem trying to explain to an 8-year-old the chemistry behind hydrogels. I was always taking things apart, never able to put them back together, just to see how they worked, asking why constantly. And I remember one day I thought, oh yeah, when my mum said the tap's leaking downstairs, oh, I can fix that. So I went armed with a hammer and a wrench to fix the leaky tap, to replace the washer. I tapped the tap and the whole sink broke in half. My STEM career nearly ended there and then. My mother, yeah, she was crazy. Anyway, so I studied chemistry after school, and I worked in industry for some years, mostly in QC labs. I worked in a food company. I worked in a perfumery company where I was involved with organic chemistry. And then my final job, and probably my most favourite, was when I worked for a drinks company who produced the little mini G&Ts in tins. Now, I volunteered mostly every week for the taste panel, a dream job. But anyway, I then stopped work to have my children. I had a child break, and really missed science. I missed it with a passion. My poor children were, were forever bombarded with, the structure of an atom, and where the protons and neutrons were, and that was when they were about 5. So when I was approached about a job at Benenden as chemistry technician in 2006, I jumped at the chance and started there. When I started, I really couldn't understand why the uptake of STEM subjects wasn't higher amongst students. Sorry, this is slide 3. Sorry. Slide 3, Catherine, sorry. So I couldn't understand why the uptake of STEM subjects wasn't higher amongst students, in particular in those subjects that weren't traditional. The school Benenden is a girls' school, so weren't traditional for girls to study. I was absolutely passionate about chemistry, physics, and all the technology subjects like computer science and design and technology, and I couldn't understand why everybody wasn't, why other students weren't. So I started to ask students, why aren't you studying these subjects at A levels? And some of the common comments were quite surprising. I don't want to be a doctor. Most students assume that they have to study chemistry to become a doctor, and if they don't have that vocational calling, then they don't need to study chemistry. I don't know what I can do with a STEM degree. Why would I do that? What can I do with it in the world of work? It's a very male dominated environment, or it's only for boys. Now that one really got me thinking. And I realised that in all my roles in the past, I'd never once had a female boss. In fact, I'd been in the minority in most of the roles that I'd undertaken in lab work. There may be 1 or 2 women in a lab, but that was it. And one student even bought me the chemistry textbook and went through it with me, pointing out that there were over 80% of the pictures or the images representing males doing science, but very few females. But the most common comments, and the even more worrying ones for me, were that I'm not good enough at physics or chemistry or science. I don't get good exam marks. I get answers all wrong all the time in lessons. I just can't do science. So they were afraid to fail. So they didn't really want to try. Slide 4. So I started to think about STEM learning in school and how we could improve student confidence and interest. Lessons are typically short, well, in terms of, in terms of science, they're 50 minutes to an hour. If you're lucky at A-level, maybe you get a 2-hour lesson. But this is not long enough for students to do real science. This isn't long enough for them to get involved in something, to really get their teeth into it and start thinking about how it can be applied in the real world of STEM. Problem solving in science lessons is extremely limited. Students are set tasks, they follow worksheets. There's always a definitive correct answer to find. With a set pathway or a recipe to follow to get there. Equipment set up for them. Chemicals are laid out. What do they actually have to do that stimulates and fosters that passion and love for STEM? This system, I think, fosters the fear of failure that many students had mentioned as the main reason for their reluctance to study STEM at higher levels. Problem solving in the real world of STEM doesn't offer a recipe style pathway to the perfect end product. We all know that, or those of us that work in STEM. It's often fraught with failures and setbacks, but it's from these failures and setbacks that we discover the most important innovations, even if they're not the ones that we initially started working on. In many instances, there's no guarantee an answer even exists, especially to the most cutting edge problems at the forefront of our knowledge. So, if we only prepare our students at school to follow a worksheet, to follow a set pathway to a predetermined end result, they're not going to have an experience of the experience of solving totally new problems, like we all do on a regular basis. We're preparing them to pass exams by the rote learning of formulas and textbook answers, but we're not providing them with the tools to build resilience and confidence, in fact, which is really necessary to make the breakthroughs in the world of modern day STEM. They need that in-depth knowledge and understanding of why they need to learn these things and how they can be applied in the real scientific environment and world. So how do we bridge that gap between the type of problem solving students are expected to do in higher education and beyond, and the problem solving they do at school? Slide 5. So this is where independent research projects come in. Independent research projects help to build knowledge and confidence amongst students. They get the opportunity to work with a broad spectrum of people from universities, industry, and professional bodies to solve real-time problems using a range of techniques, both practical and theoretical, which are often outside of the national curriculum and outside of that in-the-box thinking. These types of relationships can be symbiotic, helping all parties to move forward to achieve a common aim. There's often no right or wrong answers. In fact, when we make a leap forward in research, there are often, several steps back behind that leap forward. Students develop resilience, perseverance, and learn new strategies for problem solving, which leads to a better understanding of what motivates research and how it is actually carried out. The peer mentors who guide our project work at school don't have all the answers. They don't know, you know, the end product, because that's why they're doing research. Students are able to develop wider interests outside the national curriculum. Quite often when a student's involved in project work, she'll go on to, you know, investigate other areas that are attached to the project or linked to the project. So it's a win-win situation all round. Slide 6. We work very closely with IRIS, the Institute of Research in Schools, and a study by them found that students who had conducted research and had had the opportunity to present their findings developed a variety of new skills, not just academic, but those that were especially useful in a variety of careers, such as resilience, team working, problem solving, and creativity. Students taking part in independent research projects felt valued. They felt like real scientists whose findings were making a difference to the world around them. The current slide on the screen is just a small sample of the type of feedback I received from students taking part in project work. And I'd like to just highlight, I'm not going to read through them all for you, but I would just like to highlight one in particular. I'll tell you the story of Wendy, who, when she joined our school, was a very, very quiet student. She never put her hand up in class. She didn't really get involved with other students and was a little bit of a loner. But we invited her to join a project that we were running with University College London, the Ionic Liquids project. And this is what Wendy said about that experience. I was taking part in cutting-edge research that developed my confidence and knowledge immensely and allowed me to think beyond the chemistry I had learned in the classroom. I was involved in the research process. The complexity of the procedures involved is way beyond the A-level standard, which has certainly improved my ability to perform experiments with a high standards of accuracy. The project has also led me to research the field of ionic liquids, and from there gradually leading me into researching other fields. Now, when Wendy left the school and she actually got a place at Cambridge to study natural scientists, she was a totally different student. Confident, she mentored other students, she absolutely had a passion for all things STEM. And I really do put that down to the work that she did in her independent project work. Next slide. So we've heard all about, you know, what I think, but here's some information from our UCAS applications that might back up what I'm saying. So when I first started independent project work in Benenden about 4 or 5 years ago, I analysed our UCAS applications, and around about 6% of all our students at A-level were applying for applying through UCAS for STEM subjects at university. The majority of those were actually students applying to do medicine or veterinary science or something biomedical. They were, you know, a career calling, if you like. An analysis of our recent UCAS applications showed an increase of over 30%, with now around about 37% of our students applying for a diverse range of STEM courses, including things like material science, biomed engineering, pure chemistry, civil engineering, and economics. Why is this? Why have we had such a monumental change? And this has grown over the years. Well, I believe we now have students who are better informed about what's out there. They are making more confident choices, and they have a passion for what they're applying to do at university. They absolutely love STEM because they feel that they've been involved in a process of learning outside of what they would do in the classroom. Next slide. So, how does my role work in the school? Well, I work with universities and research bodies to offer a range of independent research in our school, and we also have 5 other schools within our partnership. And we are really, you know, we really want to encourage other students to get involved, not just our own students. So this is something that I believe is beneficial to every student in every classroom throughout the United Kingdom. Students who work on research can put their research towards accreditations like CREST Awards or EPQs, which I run. So they can actually, or they can even publish research papers. We've had students that have published research papers in the past. So this is something where, you know, a student can actually feel like they're part of the real world of science. They're doing stuff that actually influences, you know, how we live in the world today. I run seminars for students to assimilate their information to the peer mentors that are involved with, and that's the film that will be attached to this clip will show that. I organise workshops, conferences and investigation weeks so students can get a really broad variety and idea of what's available to them to study, and that I think is really important. So next slide. I'd just like to talk a little bit about a couple of the current projects where we offer at school. This is not, I'm not going to go through it all because there's a lot of information there. I'll be on the line forever, but I just want to show you that projects don't necessarily have to be practical based. So I'll take the first one. The Ionic Liquids project is a project that we started a couple of years ago, and we run with Professor Robert Palgrave of the Chemistry Department at University College London, and Professor Tom Welton at Imperial College London, who is also the current president of the Royal Society of Chemistry. Now, these guys are fantastic mentors, and what our students do is they, for those of you who don't know, ionic liquids are salts that are liquid at room temperature, and they are sort of heralded as the green solvents or the green lubricants that can replace hydrocarbons and be much kinder to the environment. So our students work on the synthesis of ionic liquids in our labs at school. We started off synthesizing basic ionic liquids that Professor Palgrave was synthesizing in his labs at UCL. And we literally have branched out from there. We now create our own designer ionic liquids. The aim being to ascertain and test the chemical properties of these ionic liquids, all the different formulations. So we would change maybe you know, a cation or an anion or some part of the formulation to test the chemical properties of the new ionic liquid that we had created. We would then feed back the information to Professor Palgrave, so he gets the opportunity to you know, increase his workforce, if you like, to increase his investigations, and we get the opportunity to work with some incredible scientists at one of the you know, the leading universities for STEM research. So it's a win-win all around. The students also get the opportunity to visit with Professor Palgrave on a say biannual basis, where they get access to the NMR machines or the mass spec machines to analyse the samples we've produced in more detail, and then that data we can then analyse and crunch when we get back to school. So it really is a very immersive project. So that's a project that's very practical. Then we have projects that can be data-based, data-led or data crunching. So we work with the Wellcome Sanger Institute, and I've just noticed a spell check error there. Wellcome should be double L. I'm terribly sorry, Wellcome. On the decoding of the whipworm, human whipworm genome. Now, this project is run in school using the Apollo software, which is the software that the geneticists at the Wellcome Sanger actually use to do their decoding. So we've had students who have been trained by me and other members of staff, or one other member of staff who learned how to use the software initially, and now those students are training other students how to use the software, and we are annotating the genome in conjunction with geneticists at the Sanger Institute. So this is incredible. In fact, we have actually, schools have actually contributed to decoding around about 70% of the human whipworm genome so far. So, and you can do a project like this at any time outside of lesson time. Students can do it whenever they like. They're given a proportion of information to decode each month, which they decode, and it's fed straight back via the program to the Sanger Institute. And like I said, you can do this anywhere at any time as long as you have a computer. and you've had the training initially. So next slide. So how can you get involved? What can you do? Well, if you're not inspired by what I've said, then please be, because students really do need your help to get into the real world of science. We're building a research community at school. We have 5 universities signed up already. Some of the universities I've already mentioned UCL and Imperial, University of Kent. We have bodies and companies who are involved as well, who offer access to their research for students to take part in. So if you're interested in becoming a mentor, or if you carry out any research that students could get involved with in any way, then please don't hesitate to contact me. I'll come to you. I'll work with you to make sure we have a safe and feasible project structure that we can take into the school's environment. And if it's not safe and we can't do it, then I will say. Obviously, safety is our first concern. So my email address is on the slide here. Please do get in contact. I am more than happy to receive emails from you. Please do. If I don't get any, I'll be really disappointed. Similarly, we're always looking for speakers from industry and academia to talk about their specific areas of interest. Well-informed students with knowledge about what opportunities are out there if they study STEM are the ones that choose a STEM career. So please let me know if you'll be happy to speak to students about what you do. In fact, during lockdown, we've set up a range of webinars that we're hosting every Wednesday between 4:15 and 4:45 for students, entitled Ask the Scientist / Expert. And I'm really pleased to say that we have a full schedule up until the end of this school year. But it's been so popular with students that we really want to be able to offer this to students next year. And it's a way of taking up a very small proportion of your time. So if you're interested in becoming involved with Ask the Scientist / Expert next school year, that's from September, then please email me and let me know. It's half an hour of your time, and I know students will be really interested to find out what you do, how you do it, and how you got there. Technicians. A lot of this work, teachers don't have the time quite often in many schools to get involved with this type of work. So it falls to technicians to support this in quite a few instances. So if you want help, technicians, in setting up independent projects or research projects in your school, I can help you. Please get in touch with me. It's so rewarding. It helps you to keep up to date with what's going on out there in the world of STEM. It's a quick career path progression, because you probably could go on to do other things if you really wanted to. But the most rewarding thing, the most fantastic thing is when just one of those students that you've been working with goes off and becomes somebody successful in STEM. It is incredible. I've got one girl that from about 5 years ago who the teaching staff were, she's not going to, she'll get a B in chemistry, she won't end up working in STEM. Well, she ended up getting a first at university for pure chemistry, and she's now bossing it on an oil rig. She's in charge of about 20 male colleagues, sorry men, and she absolutely loves her job as a pipeline engineer. So that for me is reward enough. But my crazy dream, my crazy dream is we've breached on why how maybe other schools may not have the teacher time or the lab space to do something like independent project work in schools. So okay, let's take that out to them. Let's create a STEM bus or a mobile laboratory that we can take around schools who aren't so lucky, that aren't so they don't come from necessarily advantaged backgrounds like we do, and give them the opportunity to get involved in research projects and STEM in the real world, become real scientists too. And that is the way I really do believe we are going to increase our STEM workforce in the future. Next slide. So, oh, it's the end. Well, thank you so much for listening. I hope I've done a little bit just to get you thinking, and sowed that seed of thought, and hopefully done enough to get you volunteering to come and get involved with mentoring students, sharing any research you may have or project work that you think we might be able to get involved with. One of the areas where we really do need some involvement from is from computer science and tech backgrounds. Girls seem to be very reticent to get into this area, and I really do think that if they could have experience of tech on a little bit more in-depth basis than what they learn in the classroom, so spreadsheets and things like that, they might be more inclined to study tech at higher levels. So if you have any questions, please do let me know now after this. I shut up basically, and please do watch the film. Please follow the link to the film, because I think everything that I've said to you today will be reinforced by the students that you can see on the film. So thank you. Over to you, Dean.
Okay, well, yeah, thank you, Sue, not Susan. Just in case. That was great, actually. Yeah, I've certainly learned a lot of stuff there. So, yeah, both interesting and informative. And thank you as well to all the attendees who submitted questions. I've got some of them here. I've tried to group them together the best I can, as there are a couple of questions that are around data. And just on that, you can still submit questions if you haven't already and you'd like to. Well, I'll start off actually. So how is the data that you talked about assessed? And is it truly and whole, is it reliable, basically? And also linked to that, could you provide the stats, again, just around introducing students and getting them involved as well, please?
How do you mean the stats? You mean the...
Let me just read out the exact question. It is, yeah, I mean, if we could maybe start with just the first part of that, then how was the data that you talked about assessed, and is it reliable, trustworthy?
Okay. Yes, please. I mean the data that from the practical based experiments is assessed in conjunction with the mentors from the university. I mean, the students involved with, I'll just take one project, so the ionic liquids project. They're taught how to use the melting point machines, the viscosity apparatus. They're taught how to use the apparatus initially, and then they're very much aware that what the information that they're gathering and are assimilating is going to be passed and used for real life research. So every single opportunity to provide accurate information is taken. They're all supervised when they're doing the project work. So when I say supervised, I'm there to watch what they're doing. So if I'm concerned that they're maybe not doing something properly, then okay, I can intercede. But on the whole, they are very, very conscientious, and any information that they take is recorded in a lab book and fed back to the mentors involved. So I think in terms of the data that they collect from practical work, absolutely no problems whatsoever. The data that they're crunching in terms of the programs that they use to crunch data, well, they can't really go wrong there, because the program will tell them if they've done something wrong. For the Apollo software, for example, with the Wellcome Sanger Institute, if they haven't decoded, if they don't decode the genome in the correct manner, then the program won't let them post that information. So again, they're trained, they're supervised, they're not controlled, because that is absolutely the wrong word. They're supervised. So the data that they feed back is 100%, I believe, good data that can be used.
Okay, yeah, the other part of that actually, Sue, is I'll read it out exactly as I've got it. Can you please provide the stats again of the increase of students from schools applying for STEM uni courses following you introducing this?
Right, okay. Yeah. This is actually stats from my school. This is not stats over over the whole school environment. Obviously I can't possibly give you that because I only work with one school, but my school, around about 4 years ago, on analysis of UCAS applications, we had about 6% of A-level students who are applying for what I would consider to be STEM-based courses. And I did include in that, courses like economics and things like, maths. But that increase over 4-5 years is now 37% of our current UCAS applications are for STEM-based courses. Now that includes courses across a huge and diverse range of STEM fields. It does include things like economics and math-based courses as well. So I'm only talking about my school there. I'm not talking about any other schools because that I couldn't possibly. I don't know. I haven't looked into. It would be interesting actually to look into that, but you obviously have to have schools that were working on independent research projects to be able to assess that.
Okay, thanks, Sue. And just another one. If you had, I think you'll like this actually, if you had one piece of advice to encourage someone to take up a STEM role or STEM training, what would it be?
Oh my goodness. Don't be confined by anything. Don't be confined by fear. Don't be held back by okay. Work safely, but if you believe you can do it, then you can. Don't think, STEM subjects are only subjects that you can do if you're really, really clever or you get really good grades, because that is not true. STEM subjects are really creative, and you have to be allowed to, to go outside of the box. So for example, if you wanted to be a musician, you wouldn't just sort of think, okay, that's it, I'll read the paper, I'll read this piece of music and then I'll become a brilliant musician. You'd practice, you'd play, you'd fail, you'd drive people mad with terrible music, but in the end you'd achieve your goal if you do it enough. So my advice would be, go for it. Don't get held back. Don't look at the I don't know, don't conform basically to stereotypes. Just go for it.
Okay, I think that's great advice, Sue. And there's another one here. Could we possibly chat to Sue? This person's put Susan. I hate to inform you. Chat to Sue. And could we speak to her, possibly her ex-students, or get information from you, Sue, about filling out the WISE My Skills, My Life profiles for girls to go on the platform?
You can do. I mean, I have taken the My Skills, My Life. I've gone through the training, so I'm more than happy to chat to people about it. I wouldn't say it's something that I've done a huge amount of. I have to hold my hands up here because you can imagine, being lead technician, I run the team of technicians and all the project work and seminars and everything, so I'm pretty well full on, or have been. But yeah, I'm more than happy to talk to anybody about how we can work to get more girls interested in STEM, or students. It's not just girls. I know we're on a WISE platform here now, but in general we need more people working in STEM careers. If we're to bring innovation back to the UK, if we're to really put ourselves on the map in terms of excellence, then we need more people in STEM in general.
Okay, thanks, Sue. And I've just got one last one here, if I may. Are the webinars open to any students, or is it just for Benenden School pupils?
I can make them available to any students who would like to join and send me an email. I have to do it via invitation, but I can do it via invitation, yes. I mean, it's something that we've obviously done for our own students initially, but I'd be more than happy in the new year, so in the new school year, to start this as an initiative for all schools. Yeah, 100%. I mean, I would love to do that. So if students want to join, as long as I have an email address and I know where they're from, obviously I have to adhere to safeguarding regulations, within a school environment over online. But yeah, as long as I can do that, yes, I can invite other students, and I would love to do that.
Okay, fantastic. So we're probably, we're nearly on time actually. We'll have to stop there. But thank you again for your time, and also to everyone who's participated and asked the questions. This session has been recorded and it will be saved in the WISE member resource area. And WISE members will receive a link, along with a link to the film that you talked about before. Was it Mary's, did you say?
It will actually go to show, it will go to it will help to reinforce the message that I've put over. You will actually get, I think somebody mentioned, could they speak to my students? Well, this film is you know, talking to students, so it's interviewing students about what they think about their involvement in research. So it's something really worthwhile watching if you're thinking of introducing it into your school, or getting involved, in fact.
Brilliant. Okay, and that'll be in a follow-up email.
Yeah.
And you'll also actually have the opportunity to provide feedback via a survey. And I personally would be really grateful if you could complete this, please. And incidentally, not you, Sue, but incidentally, for those of you, because I know there are a number of people listening that aren't WISE members, I would be more than happy, as I said, my role as partnership manager, or one of the partnership managers at WISE, and I'd be more than happy to discuss the benefits of membership with you, how you can help improve the gender balance in STEM, and perhaps more importantly, in your own workforce. More than happy to do that. And just on that, I can be contacted. It's d.for delta.greaves@wisecampaign.org.uk. The details, along with a mugshot, but don't let that put you off, are on the WISE website. And just a little forthcoming webinar that we have. Our next one's on the 3rd of June. And that's addressing the cybersecurity gender skills gap in the UK. Bit of a mouthful, but just as a very, very brief taster, it's about businesses in the cybersecurity industry, and they find it difficult to hire the right candidates. And despite women showing just as much aptitude in data handling and computer science generally, just one-tenth of the cybersecurity workforce is female. So also with the recent announcement that furloughed staff can take advantage of upskilling and retraining opportunities, this could be an ideal time for companies looking to find out more about how to attract more women into a tech or cybersecurity career. This WISE webinar brings leading professionals together to discuss the options available to women talking or thinking about retraining into a career in cybersecurity, the career possibilities open to those with the appropriate data and tech skills, and the training and funding opportunities available to companies looking to upskill staff. So I do hope as many of you as possible are able to join us. That's on the 3rd of June at 2 p.m. for that webinar. And all that's left for me to do is to once again thank you all very much, particularly you, Sue, for joining today, and we'll finish the webinar now. Thank you all. Goodbye.